All right, in class, we looked at linear functions, we looked at graphs, we looked at linear functions, we looked at tables, we looked at how to tell if it's a linear function based on a set of data, which we essentially put into a table. Now we're going to look at the equations. Equations are much more useful because equations kind of give us to infinity. We can pick any number and put it into an equation and get a result from it. And so we're not limited to the size of the graph. We're not limited to the number of entries into a table or a set. And so equations are much more versatile and much more, well, give us a lot more resources. However, a little more challenging, a little more difficult because of that infinity, because you don't just have a limited number of entries or a limited amount of space, you have to consider to infinity and beyond. And so we've got a linear equation, and one way that we can tell if an equation is in fact a linear equation.
Anthony Campbell, please come to the office immediately.
Looking for Anthony. I don't know if you can hear that on the speaker or not. So, sorry, getting back to what I was saying. Linear equation, we're looking at how can we tell if it's a linear equation. Linear equation is if we can put it in what's called standard form. So standard form, which is what we have right here, the standard form is ax plus by equals c, where a, b, and c are all real numbers. A and b are not both 0. And so we've got, if we can put an equation in this form, ax plus by equals c, where a, b, and c are numbers, and a and b are not both 0. So an example of that would be if you had, let's say, 3x plus 4y equals 5. That's an equation, or linear equation. Right, it's some number x plus some number y equals some number. If you had 7x minus 3y equals, I don't know, 205. We've got 7x says minus 3. However, remember that anytime we have a minus sign, we can always do plus negative. So it's 7x plus negative 3y equals 205. And so your A, B, C, and your A, B, C. It's as easy as 1, 2, 3. So we've got our linear equation. Now a couple things to notice. I'm going to have you write this down. A couple things to notice when you're looking at these linear equations. This deals with linear equations. There are other types, but we're really concentrating on these linear ones. Is that when you have a linear equation, x and y both have an exponent of 1. Right, so there's no x squareds. There's no y to the third power. So x and y both have an exponent of 1, which means we don't normally write the exponent. There's no other exponents. So if you see extra exponents, not linear. X and y are not multiplied together. They're added. Ax plus by equals c plus. No multiplication with x and y. X and y do not appear in denominators. I didn't write any examples of that. However, you certainly could have, I'm kind of running out of space, you certainly could have 1/2 x minus 3/4 y equals 7. A would be 1/2, B would be negative 3/4, C would be 7. And so you could have that, but no x and y in the denominator. X and y do not appear in denominators. Oh, exponents, no x or y in the exponent. So again, you couldn't have y to the x power. That would be what's called a power function, and that doesn't work. It's not linear. Or radical signs. And radical signs, that's not like, dude, radical. No, a radical sign is like square root of x or square root of y. Those are called radical signs. And so no radical signs, no square roots, no exponents. X and y are not in the denominator. They're not multiplied together. And there's, no exponents. Okay, let's look at some examples. So we're going to be asked to identify some functions, some linear equations, linear functions. So we're going to be asked to say, is this a linear function? Tell whether the function is linear. If we can get it in that form, ax plus by equals c, then we know it's a linear function. It's not quite there. We've got x equals 2y plus 4. It's not quite in that form. However, I could solve and try and get it in that form Well, if I want to get the x and the y on the same side of the equal sign, I want them to be on the same side of the equal sign, let's move these two y's over here. So I really have x minus 2y equals 4. Remember, x's and y's are different, so we can't combine them together. We can only combine our like terms. It's almost there. We've got the x with the x, we've got y's with y's, and we've got an equal sign where it's supposed to be. We still need to remember that we have to do plus negative. And so now we have the plus. We have a b. B would be negative 2. Y is in the right spot. X is in the right spot. There's no number a. Well, really, a is 1. There's 1x plus negative 2y's equals 4. So tell whether the function is linear. Yes. Yes, it is linear. And in fact, you could even list out what a, and some of your assignments might have you do this, a, b, and c are. So a would be 1, b would be negative 2, c would be 4. So yes, in fact, this is a linear function, a linear equation. Try this one. See if you can tell, is this a linear function? And if it is, what are a, b, and c? I'm assuming you paused. I'm assuming you tried it on your own. If I go back here and kind of do a double check on what it has to have, both the exponents are 1. Yep, no exponents, so that's good. There are no radical signs. X's and y's are in the denominator. Nope, x and y, there's no fractions to worry about, so that's good. X and y are not multiplied together. So if it is a linear equation, the x's and y's are not multiplied together. X and y are multiplied together in this case, so this is not a linear function. So tell whether the function is linear. You can say not linear. You can just say no. Okay, pause it. Try it on your own. I'm assuming you tried it on your own. Tell whether the function is linear. If so, get the equation in standard form. I'm not going to go through the whole process of solving them. You can look at the linked videos or the videos below on your own. The first one, yes, this is a linear function, and I'll link it so you can see how we can tell later, and I'll write it in standard form. The second one is yes. The second one is a linear function, and again, go to the linked video. If you're looking at that and going, what? How can that be linear? Go to the video. Watch how it's done. And the third one is no, the third one is not a linear function. Again, go to the linked video if you're not sure why, and watch how we can tell if it is. I will also get the equations into standard form from there. And so you can check those and make sure that you're doing things correctly, and then give the form a try.